So it is my pleasure to introduce Dr. Max Durhack, who will be presenting today about ICC Max and the future of color profiling. Max is the principal scientist at Onyx Graphics. He received a PhD in color science from Rochester Institute of Technology, where Max was instrumental in the development and setting the international standard commonly known as ICC Max. Max is the co-chair of the ICC and is actively engaged with organizations including ISO, CGATS, and CIE. Max has been with Onyx since 1990, has received 10 US patents for his work, and leads the product development engineering team on projects that are related to image processing, color management, as well as process control tools. So thank you again for joining us. Thank you, Max, for being our presenter. And I will turn over our presentation to Max.
Thank you very much. It's good to be with you this morning or this afternoon, depending on where you're at. Today, I'm going to be talking about ICC Max. This is a topic that I'm really interested in and I love to talk about. And if this is not going to be a seminar where I'm going to give great technical details about ICC Max, this is more of an introduction. The ICC Max can get really involved. But the real key here is we want to understand the basics of color and color management, because you really need to understand that in order to understand why ICC Max came about, and then what's involved with ICC Max and where it can make a difference. Spend a lot of time on areas in the universe where ICC Max makes a difference, and then we'll kind of wrap up with talking about ICC Max in Onyx software. As it was mentioned before, I have a doctorate in color science, and color science is actually something that's rather quite involved. And really, in order to understand color, you got to understand that color is not an object. Color is not a light. Color is a perception. And really, it involves basically a rather involved process. You start off with some form of light. It could be a light bulb, it could be the sun, a candle, some LEDs, or it could actually be coming from a display. And that light is either directly observed by a human with light sensors in our eyes, or that light will interact with objects in some way. In some instances, the light will actually go through the object and be somehow modified in the process, or the light will interact with surfaces and also potentially be modified potentially in some way. We'll talk a little bit more about that. Now, once the resulting light gets to the human observer, then you have cones and retina inside your eye that basically convert the light impulses into electrical, chemical things that go into the brain. A huge portion of the brain is associated with taking that information and trying to make sense of it. And really, basically, in making sense of it, you end up with a perception. And the real key here is color is ultimately the perception. It's not in the eye of the beholder, but it's in the mind of the beholder here. Now, this really is super important to understand, because when we're talking about color management, and that we need to understand all of the things that are involved in this particular scenario here. Now, one additional thing to understand is how light interacts with surfaces, because light does various different things. Light can basically come in and bounce off the surface like a mirror, and basically it comes in at an angle and goes at an angle opposite to the angle it comes in. No change to the light is really made other than potentially the bounce. And a secondary thing is the light can come into the object, and it goes in and it gets absorbed by some molecule somewhere along the way, and that's the end of the light. It potentially changes the temperature of the surface or gives it more energy, but other than that, the light is gone. Now, this can happen for photons of light of different wavelengths. So some light may come in and do one thing, some other photons may come in and do something else. And so really the resulting light that comes off of a surface for all the different wavelengths of light end up being basically the sum total of the light coming off the surface. Um, with reflectance, light comes in and it may basically bounce around between molecules until it comes out, coming out potentially at a different angle than the light was coming in at. Or the light can go through and go all the way through the object and bounce around. Another aspect where light can come in and be absorbed, but it doesn't hold on to that energy. And so the molecule essentially release that energy as a photon of light, but at a different wavelength. So the light will come in as potentially blue light and come out as green light, or come in as ultraviolet light, which we don't see, and come out as some other wavelength that we can see. And finally, light can come in, and if you have a really, really, really thin surface, like an oil film or a bubble or a video disc, um, then the light can come in and basically not bounce off the first surface, but bounce off the second surface, come back up, and then interfere with the light coming in from the surface and essentially cancel out. And that's how you end up getting all sorts of fun colors in terms of bubbles and these kind of surfaces. The real key here is that all of these different ways that light interacts with surface provides challenges for measurement as well as understanding what the visual appearance is. Okay. So what is color management? Color management basically involves communicating about color experiences. Okay. And there's two of the aspect to it. What is experienced? Okay. You know, what are you actually seeing? Okay. And that's color modeling. We're trying to understand sort of essentially, the principles of what are the inputs going into this experience so that you get it. For instance, what are the actual phosphors on the display, or that define the color, or what sort of pigments and inks and stuff like that are involved in the surface. And color modeling is basically determining, sort of taking those color ingredients and figuring out what experience you would actually have. And the second aspect about communicating with color experience is basically what is the expected experience. If I want someone to actually see something, have an experience of color, then I need to understand how to make what I need to change in terms of my controls in order to get the experience that I expect. And that's what we have in terms of color reproduction. So with that in place, then let's talk about why ICC Max. We have the ICC color management. It's been around for many years. It works most of the time. And the real key to understand with ICC color management is that basically it makes color reproduction possible, but it simplifies the situation. Basically, the premise between ICC color version 2 and version 4 color is that it basically assumes that you actually are viewing something under daylight, a specific daylight that was defined in the 1960s after lots of experiments, and it doesn't necessarily correspond to any particular experience you may have because it's a theoretical definition. And then you have a surface. um, and it's assumed that basically the surface is diffuse, that the light will basically be reflected every direction, in the same amounts. It's kind of a matte surface. And then there's assumptions about who the observer is. Additionally, it makes assumptions about the for displays, that the display will be basically doing light with the white point of daylight. When you actually look at it, basically we have a standard daylight, a matte surface, a observer has specific color matching functions based upon experiments in the 20s leading to the 1931 standard observer. And that gives us basically numbers that basically correspond to color experiences. Okay. Um, if the situation varies at all in any of those, in terms of the complexity of color, and as I started off, I'm saying that color is actually potentially a whole lot more complex than this. Nobody's the standard 2-degree observer. You're not going to necessarily be under a D50 light source. You potentially have gloss on your surface. Um, um, if those things change, then the color prediction and the ability to reproduce the experience is therefore limited. Second aspect is that version 2 and version 4 are limited in terms of how it describes things, how you can basically do the color modeling or how you can do the color reproduction. And basically, to basically do color conversions, you have to be able to express it in a series of transformations. Okay, you start off with one-dimensional lookup tables, or changing each one of the individual inputs independently. You have a lookup table that uses interpolation. You have another set of one-dimensional transforms that modify the results. You can pass that through a matrix and then put that through one-dimensional lookup tables. Now, not all these transforms you can basically have to have this sequence. You can leave some out. The data that's encoded in the profile is encoded as integers. And all these transforms, like these one-dimensional lookup tables, they're basically just like tables you might think of in terms of a spreadsheet. You basically have the input values and the resulting output values. And the real key here is that not every possible value is put into the lookup table. It basically has spaces between them, and then we're using math in between them to interpolate and figure out what the results are. And with larger tables, with n-dimensional lookup tables, you're basically putting in combinations that are actually 4-dimensional and then interpolating between those 4-dimensional to get the resulting LAB values that for a model. Now, a big challenge with using lookup tables is as you have more and more channels, the number of entries that you have in the table gets larger and larger. In this previous example here, you're basically doing every combination of 0, 33, 66. So you basically have 4 combinations of cyan, magenta, yellow, and black. So in that case, if we have those 4, the number of entries that you have in the table, oh no, that's not 4. This would be for every 5%, not every 33%. Sorry. But if you start off for 5% combinations, if I have just one dimension, I have 21 entries because you have white and then every 5% going up. And there are basically we're going to always be interpolating between 2 points, a lower one and an upper one. When we have 2 dimensions, basically we're going to have 21 times 21 or 441. With 3 channels, we end up multiplying that by 21 again and again and again and again. By the time we get to basically 6 or 7 channels, if you had 7 channels, that's CMYK, red, green, blue, which is something that the industry is actually exploring at this point in time. You almost need 2 trillion table entries. Now, each table entry potentially has multiple values for an LAB value, and each one of those LAB values are going to have 2 bytes associated with them. So you're actually looking at really, really, really big profiles in order to have basically the same accuracy as having a 5% sampling of 2 channels, going with only 441. In general, it's to the end. It's exponential. It grows big. And the challenge with ICC profiles is that with larger channels, you really have to basically lower the number of steps. So rather than doing steps of 5%, maybe do steps of 33%. And that makes the profile much less accurate in terms of its ability to be predictive. And we also have limits in terms of the connection functionality. If you want to match displays, the real key is to assume that the light coming in and the light coming out, and the light is basically a normalized so that basically it's relative to the peak light, and that's all you have. And so if the peak light changes between light sources, that's not necessarily even something that you actually have information about in the profile to do stuff. Another challenge is that basically display matching can become a real challenge. Um, um, as displays get more and more advanced, they use narrower and narrower primaries. I mean, in quantum dot technology, the primaries have very, very narrow wavelengths. And the challenge is that ICC version 4 color matching assumes basically a specific set of color matching functions for the observer. And there's very wide variability in observers. And so what will happen is that when you're actually trying to, calibrate or set up a calibration for a display, different observers are going to see the same display differently, and especially when you get quantum dot. And if you got critical things where you're actually doing color retouching or something like that, between one observer and another observer, there may not necessarily be an agreement, and so that's a bad thing to have. So the real key about version 2 and version 4 is it works, but it has simplifying assumptions. It simplifies about the idea of what the light source is. It simplifies basically what you have in terms of what you can model of surfaces. It simplifies the what you understand about the observer, and the actual transformations that are in the profile themselves are fairly limited. So with ICC Max in the ICC, I've been with ICC for many years, we were looking at all of these potential limitations. We're thinking we'd like to be able to actually have color management that basically allows us to basically describe more of the characteristics of what's happening in the real world when the assumptions that are made by version 2 and version 4 profiles don't make sense. And so after many years, the ICC developed a standard, which is basically a standard within the ICC organization, as well as it being an ISO specification. It's ISO 20677. The idea behind ICC Max is it extends the basic concepts of version 2 and version 4 to allow for a fuller communication about a color. It doesn't fundamentally change the processing model of profiles. It just makes them so that you basically have more capabilities. We'll get into that. It defines an extensive things of what you can put into a profile. It defines CMM processing and transform operations that, with what we can put into a profile and how they're connected together. And it allows for lots of different color matching workflows to be addressed by separate workflow documents. Let me explain that a little bit here. So if we think about version 4 version Max, you can think of version 4 and version 2 like a basic Lego set. You have basically a very limited set of building blocks for doing color management. And as long as you want to do that, you can do stuff. And really, ICC Max, like adding things to the basic set, ICC Max provides additional capabilities so that you can answer and ask more complex questions related to color management, all while maintaining backwards compatibility with version 2. It's kind of like adding different things. You have programmability in the profiles. You have more complex transforms that can be encoded. Now, the real thing is that ICC Max defines this huge, it's like a big box of Legos. And when you're actually doing stuff, you may not necessarily need to use all of them. And one challenge in terms of thinking about ICC Max is if I'm going to implement ICC Max, what from ICC Max am I going to implement? Do I have to actually use every one of these tools that we actually have in ICC Max? And so the ICC is also in the process of defining interoperability conformance specifications, which really define smaller kits built from the master set of building blocks. So only a limited number of things are actually needed for ICC Max or used. You can think about doing, say, I want to have an ICC Max based defining things for doing things with the monitor, or I want to have ICC Max for doing things for printing where I actually have spectral information, and what the idea of it is that basically products that are developed, they can choose which ICS workflows they want to support, And this really allows for the ICC Max specification to grow and evolve as new workflows are needed or people are identifying things they want to do that are limited. And this can basically done. And what will happen is the ICC Max will grow, but it won't necessarily change the fundamentals of the ICSs that are based upon subsets of the ICC Max specification. So that's kind of the thought process or the motivation behind ICC Max. Now, let's talk about sort of there's really two basic things that ICC Max is going to bring to us. First of all, you have more flexible transform encoding, okay? And it starts off with, first of all, the numbers in ICC Max profiles use floating point encoding in addition to integer encoding. You have a flexible ordering of processing elements. You don't have to have a specified sequence of processing elements. You can use processing elements in any sequence that you really want. And you have the options to potentially have additional processing elements that aren't necessarily available. You have a programmable processing elements. You have the ability to have matrices that are larger than 3 by 3. You have the ability to put spectral information and transforms that are based upon spectral information rather than just colorimetric information. And by allowing this kind of flexible stuff, what this does is this allows an algorithm to be directly encoded in the profile. Rather than having a lookup table for 7 dimensions, you can basically define math, maybe using some lower dimensional lookup tables to actually accomplish the transformation. And the real key here is that this basically allows for profiles to be much smaller and potentially much more accurate because it's actually, rather than using linear interpolation, you can use whatever algorithm you really want to actually do that. And so, an example on the side there is basically a kind of a transform that would do 12 channel proofing profile that would basically give you any combination of 12 inks and what the actual color is. That would be basically something that would be under 3 or 5K, which would be impossible to do really practically in a large n-dimensional lookup table. In addition to flexible transforms, there's a lot more flexibility in terms of how colors are handled. ICC Max allows for custom observers and illuminants to be specified and used in the transformations. You can basically define color using spectral representation. So we can define the spectral power distribution of a light source. We define the color matching functions of the observer, and we can talk about the spectral characteristics of the surfaces in terms of spectral reflectance or spectral fluorescence. We can account for surface characteristics in terms of how light reflects off the surface. You print on a glossy media, you have the gloss. And so the gloss itself can potentially be accounted for in terms of an ICC Max profile. Luminance characteristics can be communicated so that you can get matching between different light booths or displays to make sure that they actually look closer to being the same. You get better representation of color gamuts with a 3D representation of the gamut rather than basically doing some interpolation in an n-dimensional lookup table. You can account for the directional aspects of color coming off a display from where you're looking from and that. In addition to, there's a flexible connection of color channel data. I'm going to go into a little bit more description of these kind of things, but the real key here is that ICC Max allows for much more complex aspects of color to be characterized and communicated and modeled. So let's talk about what things can be done with ICC Max that can't necessarily be done with version 2 and version 4 profiles. And this right here is more of a vision statement than it is of what you're seeing in terms of the adoption of ICC Max at the moment. The first one would be smaller, more accurate profiles, okay? The idea of being able to program various different things. At the top here is basically defining the transform elements that you really want to have done. And this is actually something that we're using in Onyx in terms of our building of ICC Max profiles. We're basically changing the order and the transforms we have. Rather than storing the information in a ICC profile as Cartesian coordinates using LAB, we're converting it into polar notation, which corresponds to more perceptual aspects of lightness, chroma, and hue. Various hues have more need for performance, and we can basically sample the chroma much differently so that we actually get a representation inside of the profile connection space that corresponds to a more perceptually uniform understanding, therefore giving us potentially more accurate profiles with smaller profiles. For presses, you can basically encode an algorithm directly to get to express the information about the color handling. Backlit display matching, which was mentioned before. Basically, you can, and there's multiple aspects about the backlit display matching. You can characterize the luminance level so that you actually get the relative brightness to be the same. But you can also, in terms of backlits, you could have one backlit has a fluorescent light source, one backlit that has a LED-based light source, and maybe another one is based with conventional tungsten light bulb. And each one of those have completely different spectral characteristics, and those spectral characteristics are going to interact with the spectral reflectances of the transmissive media that you're doing. And so in order to actually get matching, you not only have to take into account the differences in brightness levels, but you also need to take into account the differences in the spectral characteristics of the light sources that are being used. And with ICC Max, you can potentially have a profile that just characterizes the spectral reflectance of what's printed, and then the light and the brightness levels can actually be separately accounted for within the ICC Max processing models. We have extended display characterization. You have high dynamic range. I mean, ICC version 4 is somewhat limited in terms of what it can do with high dynamic range images, which is something that's becoming more and more popular with cameras that have multiple phones that have multiple cameras in them. In addition, for the medical industry, they have what's known as the grayscale display function, which takes into account the ambient lighting conditions so that you're basically always able to reproduce just noticeable differences. Because if things disappear, that can affect the diagnostic capabilities of the person looking at the display. And ICC Max allows essentially an algorithm that characterizes the grayscale display function directly. You can do spectral-based imaging rather than colorimetric-based imaging, and this basically is everything from capture to print and keeping track of images in between. Cameras can have more than 3 sensors, and that information can then be used to essentially estimate the spectral reflectance of the actual surface. Then you need to have the ability to actually communicate images with that spectral information. ICC, I mean, in images themselves, what the color is or what it means is defined by the profile. And with version 2 and version 4, you can only define things colorimetrically. With an ICC Max, you can now have images that are spectral images that tell you essentially how that image will look under any light source for any observer. And then you can take that spectral information and take a printer that has more than 4 inks and take into account and try to better reproduce the spectral characteristics of the imagery. You can handle differences and predict changes that occur in lighting. And really the idea here is basically with different light sources, you have different spectral power distributions. Over here in the upper right-hand corner shows some of the actual spectral power distributions of different kinds of illuminants. The kind of the small wiggly ones would correspond to daylight illuminants. The one that this here corresponds to tungsten, and then the spiky ones corresponds to fluorescent lighting conditions. Each one of those things are really very different, but potentially they can actually look the same. But what will happen is that different objects, when they go from one light source to another light source, will actually change their appearance. And with ICC Max, when you actually have spectral reflectances in, say, a printer profile, you also specify the light source that you want to use, and you can potentially replace that and predict how things will change for different light sources and different observers. Um, Another big thing that ICC Max brings to the table is that it goes beyond spectral reflectance. Surfaces that fluoresce, where the light comes in at one wavelength and comes out at a different wavelength, are completely not handled within ICC version 2 and version 4. And anybody who's tried to do color management where they actually have optical brighteners in the textiles or optical or inks that fluoresce will attest to the fact that color management is very, very difficult to do. Most times you're just kind of guessing and trying to apply different things to see if you can find something that works. Fluorescence is something that's very common in various media, and the industry has done a lot to try to standardize on viewing booths so that you can say this is how it will look in a specific location. It doesn't predict anywhere else, but for that specific location. But with a spectral fluorescence model in a profile, you could potentially predict how things would look depending on any light source with anything going into UV and the infrared. Another thing that came up in the process of developing the ICC Max specification is that, in photography, people have hundreds of thousands of images. And if each image has an ICC profile and they're all saying, hey, this is sRGB, the profile defines essentially transforms to go into and out of things. Well, ICC Max has the ability to have lightweight profiles that basically just say, hey, I'm sRGB. It's a much smaller profile. It still basically defines what the color is, but it doesn't define how to do it. The CMM takes one of those profiles and says, oh, you're sRGB. Well, you need to use this transformation. And so you have that ability to do it, thus reducing the amount of information that's communicated in images. You can take into account the dependency of lighting and viewing angles. ICC Max has the ability to encode bidirectional reflectance functions. And what this really means is basically we can account for basically the angle of the light coming in and the angle of light that you're viewing from. And this allows for basically one to then say, I want to know what you can do 3D modeling on a display that shows how gloss will be effective. And this is really important for things like the packaging industry, where they use metallics and specialty colorants that actually do different things based upon the viewing angles, and having the ability to actually have color management for your display so the designer can see what it looks like as they're designing their images and their documents. Makes it very useful because every step of the way you basically see what you want to get and get an understanding of what's going on in terms of reproduction. And another example of it is not just gloss, but also the fact that the color itself can change based upon the viewing angle when you actually have pearlescence. Also for displays, LCD displays, at least some of them when they first came out, were very, very sensitive to the viewing angle. And so you can actually define an ICC Max profile for such a monitor, where you actually have something that tracks where the observer is and adjust the color so that you get a potentially consistent experience depending on where they're at. Version 2 ICC profiles have the ability to define name colors, but all they allow you to do is define the name color by the solid tints. But if you really wanted to have percentages of tints, you had to assume something. You take a percentage of the solid color, which may not necessarily be the case. With ICC Max, the name color representation of colors in ICC Max allows for multiple tints. In addition to, each one of the name colors can define colorimetry, spectral characteristics, even fluorescence. Um, so you have a much more robust ability to actually deal with uh, libraries of named colors and how they're reproduced. You can account for the differences between observers. This is one of the areas where people don't necessarily have a real common experience because we only see the color the way we see color. And I don't really see the color how somebody else does. You can have somebody who's colorblind, or you can have somebody who's just somewhat different. Over here on um, the right is basically looking at color matching functions for normal observers, but the variability based upon age and the viewing angle that's involved with it, can really change the nature of the color matching. And as a result, especially when you're talking about displays that have really sharp spectral characteristics like quantum blot displays or even laser displays, what'll happen, and it's really most common in things like gray, where one person will see, well, this is blue, and the other person will say, no, 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 that's gray, no, that's green, and there's not they are seeing the exact same thing, but because they actually have differences in their sensitivities of their cone receptors, they are actually seeing different results. And so you can potentially have a profile that has the observer color matching functions and have that applied to a display where the display itself will take into account the observer and be and adjust based upon the observer so that you basically get more consistent experience um, and for between observers. Not necessarily at the same time, though. We can also describe and visualize color with what it is. Um, in many cases, we describe color in terms of colorimetry. We can describe color in terms of, how it responds to light. But in many industries, what you really want to understand is basically there's meaning associated with the color. If you have uh, a satellite imagery, you take spectral information about the satellite imagery, and then what you really want to do is you want to say, well, what's the probability that it's grass or trees or ocean or buildings? And so the real key would be is that you'd want to actually communicate in terms of those things rather than the color. And so ICC Max has the ability to essentially have transformations that transform from sensor symbols, sensor values to what aspects of what it is, and then you can basically take aspects of what it is and then give information for viewing purpose. Another aspect is in the medical imaging field, where multispectral images are taken to actually predict the possibility of having various disease states. And in the fine arts industry, what they want to do is for retouching and stuff like that, they really want to understand potentially what's the probability that a color is a specific pigment, so they can figure out and match the pigments to do the retouching. Lots of cool things that can be done with ICC Max. Lots and lots of really exciting things that can be done with ICC Max. ICC Max and Onyx graphics, we've only begun to touch the surface. Our goal was first to at least provide the ability to apply and use ICC Max profiles and the ability to use some limited additional features from ICC Max profiles. It's not the end. We're just beginning, okay? First of all, to use an ICC Max profile is not much more difficult than to use a version 2 or version 4 profile. You just select it in the ICC profile selection. If you have an ICC Max profile, select it, and it gets used and applied properly in the software. If you have an ICC Max profile that's processed that's built for your when you do profile as part of the profiling process, then there's not even anything to really select into it. All it does is it automatically gets applied as part of doing the processing to print the image. Building ICC Max profiles. It's a feature of version 19, and building ICC Max profiles is really quite simple. you just go down and you select the ICC version and you select version 5. Once you do that, you're building an ICC Max profile. Now, the ICC Max profiles that are built in by Onyx version 19 have essentially two specific, actually it's three specific things. Um, the first one is that basically we're using polar notation to represent the things, the lookup tables for uh, for doing the color rendering of output. And by using polar notation, we actually end up with a much more perceptually uniform representation of color space. We're also able to represent colors that you can't represent with version 2. So those are really high chroma colors that you don't see. This results essentially basically having a little bit more accuracy represented in the profile uh, of for the same size of profile. Additionally, we have the ability to represent. We're now putting the spectral characteristics that we get from when you're actually using a spectrophotometer into the ICC profile. So at some future date, we can actually do things like saying, well, what does it look like to this observer under this light source, and get a preview on the screen of that information, because we now actually have that information in the profile. Hasn't that implementation hasn't been done, but the building of that information is now in ICC Max profiles for future enhancements to the software. And the last thing is that we also now encode the measurement data that's being put in the profile. That's now compressed to make the profile smaller. So in conclusion here, ICC Max is a really awesome, wonderful thing. I've enjoyed working on it. I really enjoy understanding color and doing good things with it. Uh, ICC Max basically it describes the real world. That's really the goal of ICC Max, is allow for all aspects of color to be characterized, modeled, and processed and reproduced. And it does that with basically a flexible and extensible platform for doing the modeling and defining color workflows. And the complexities of real color in the real world are encompassed. ICC Max is available in Onyx version 19. It comes standard in Onyx 19 products that have profiling. Products that don't have profiling can apply them, but they can't build them. Existing Onyx customers can upgrade to Onyx 19 through their Advantage subscription. And if you want to get more information, you can contact your authorized reseller or email sales@onyxgfx.com. And that's what I have for today. Any questions?
Max, thank you very much. Really appreciate you explaining the ICC Max. I even learned a little bit more about utilizing ICC Max and color in the whole world. So that's terrific. We do have a couple of questions, Max. If I'll read them to you and let you know if you want to. We can move forward with answering them. One of the first questions is there any idea when or if Adobe will support ICC Max profiles, functionality in Creative Cloud apps?
That is the $50 question. And unfortunately, I don't have that answer because that's Adobe. And Adobe has not necessarily announced that they're planning on support for it. They are involved with the ICC. They're involved with the standardization. The last ICC meeting, we had an Adobe representative. They're helping to work on interoperability conformance specification documents that basically provide the limited aspects so that potentially they can use those things. But when they're going to do something, I don't know. The other thing here is that ICC Max is a conceptual thing that really requires people to understand it and get behind it and request it. Adobe, they're deciding, well, is anybody going to use it? And why should I put the effort into it? And until people actually go to Adobe and say, you know, I have this pressing need and you need to help give me support for this, you know, they're not necessarily going to do it. But there's not, the ICC can't force anybody to implement anything. Um, I'd really love to see, I really love to see it, and I think that it would be very valuable. But it's something that's up to Adobe at this point in time.
Great. So there was another question as well. What is the difference with building a profile for a printer with specialty inks using an ICC version 4 versus the ICC Max? Is there a processing difference? Will there be a visual
There's
difference?
two questions actually there: building a profile and processing the profile. So let's talk about that now. At this point in time, the our use of capabilities ICC Max, though we have, you know, we've used some of them, we've only begun to scratch the surface. Um, if you're talking about specialty inks, we could talk about various different aspects of specialty inks. You could talk about specialty inks that fluoresce, or you could talk about specialty inks that like metallics, where it you know, you have differences in how the light reflects off the surfaces. In those cases, the first thing that you need to be aware of is that a spectrophotometer is going to be insufficient to give you information about that. You need to have different measurement devices. You need to have a device that basically tells you, for fluorescence, you know, given a wavelength of light coming in, what wavelengths of light can come out. And so that requires a spectrofluorimeter, not a uh, spectrophotometer. So the first difference would be you'd need to potentially have different measurement devices, or if you have something that with metallics, you need to actually have a measurement device, some sort of device that shines light at different angles and measures light at different angles in order to actually get that information, to then provide that information to put modeling into the profile itself. Um, and then in all actuality, when you're actually talking about the processing of it, then there's also differences there too as well, because you need to actually have information about the light source that gets passed in, potentially information about the angles that are involved, so that you could potentially do like an on-screen 3D preview of things. So the real key is that we're only going to be beginning to see the possibilities of ICC Max, but it's also going to require changes in infrastructure and changes in uh, um, technology that go into building profiles.
There's another question, and I would think that this is related also to profiling. Can you adjust the color to accommodate different observers?
Well, that's what happened. I mean, that's really the idea um, uh, behind having this information. If I have spectral information in an ICC Max profile, and I have information about the light source and the observer, then a CMM can take that information and basically come up with the colorimetry specific for the observing condition. And then, uh, you know, in terms of like building something like a device link, you could actually build a device link that actually would then have the adjustments for the observer to get the matching for the observer under the specific illuminant. We don't have that yet, but that possibility exists.
And then in regards to Onyx, utilizing our quick sets, the question is, can the ICC Max be used with a quick set that are profiled with ICC version 4? So can you use
I mean, you can use ICC Max in version 2 and version 4 profiles. Basically, when you specify profiles, well, let's take, for instance, let's do the very simplest case. I profile my printer and I profile it using a version 5 profile. At that point, I'm using a version 5 profile. In my quick set, I set up the profiles that I want to use. I use a version 2 sRGB profile. I use a version 4 CMYK profile. And when we go to process, the CMM will basically open and use the version 2 profile, and then use the version 5 profile to do the output, or vice versa. You could potentially have a version 5 input profile going to a version 2 or version 4 profile. And the ICC MAC specification defines basically the profile connection condition transformations that need to be done by the CMM to provide for that compatibility. And so there's a very rich, robust definition of things that go on inside of an ICC MAX profile to make that backwards compatibility possible. And then when you actually have version 5 connected to version 5, you may actually have more flexible options that need to be controlled and configured in the application itself.
And then also building a profile with ICC MAX, is it the ability to do iterative processing as well?
Iterative profiling?
With ICC MAX?
I'm trying to understand the iterative aspect of it. So
maybe utilizing the AccuBoost with the ICC?
Yeah, I mean, the real key is you could potentially have, I mean, the one thing you have with profiles is you're trying to basically, when you're profiling a printer, you're really trying to come up with a model of printing. And one of the tricky parts about profiling printers, especially CMYK, is generally the amount of samples you have with more and more black gets smaller and smaller when you print with, and so you potentially want to pick your black generation that you're going to be used, and that's the whole principle with AccuBoost. AccuBoost applies just as well with ICC MAX. It doesn't necessarily change the nature of the input and the output. It basically potentially changes how we do transformation in the middle. And really the whole idea of AccuBoost is really basically using more information for a specific situation that you didn't have to begin with. And that'll apply with ICC MAX profiles just as well.
So last question, there was a question about resources and where you can get additional information about ICC MAX.
I would say that at this point in time, the ICC website is a very good place. We actually have lots of different seminars. I mean, this is basically kind of one sample of a seminar I've done. We've had developer conferences. It's a learning process to understand. We have various white papers that we've published related to ICC MAX for users and people who are thinking about implementing. Getting people to implement, there's interest in it. I can't necessarily tell you all the people who have done it. I do know that Onyx is the first to actually have an implementation of ICC MAX. I will publicly state that it's not the be-all end-all implementation, because there are lots of capabilities and features of ICC MAX that we really don't necessarily have incorporated yet, because we are starting from where we're at and growing it as we go.
Well, thank you again, Max. Thank you very much for presenting today. We appreciate it. And thank you for everyone for joining. Please feel free to visit onyxgfx.com. Please feel free if you'd like to email myself. Again, thank you very much. We really appreciate it.
My pleasure. Thank you very much.
Thank you. This concludes our meeting. I'm going to end the WebEx.